Hello, we have here a mass hung on a spring. It's resting peacefully at this equilibrium position. Of course, we are going to disturb it. We are going to displace it from this position. And it will go into what's called a simple harmonic motion. If we plot on the graph how the displacement x varies with time t, we get a very beautiful sinusoidal graph. If I ask you for a mathematical expression for how the displacement x varies with time t, what would it be? I would say x goes to x naught sine omega t. And you'll say, why sine? Well, I start my graph from when the oscillation is at its equilibrium position and going up, and that's why I see a sinusoidal function. If you start your graph from when the oscillation is at its topmost position, then you're going to get a cosine graph. I could have started my graph from when the oscillation is at its equilibrium position but going down, then I would have gotten a negative sine graph. You could have started the graph from when the oscillation is at its bottommost position, and in that case, you have a negative cosine graph. And all these are equally good. But today, I feel like the sinusoidal function, so let's go sine today. Okay, first of all, this x naught thing here, x naught is the amplitude of the oscillation. It's basically the maximum displacement from the equilibrium position. Yeah, it's oscillating, but there's a maximum displacement. That's called the amplitude. More interesting will be this thing here, omega, yeah? Omega, not W. So omega is called the angular frequency. Can you figure out what is the unit for omega? Now the unit for omega t should be radian, yeah? Because the sine function can only take an angle, and angle has the SI units radian. So if omega t has the units radian and t has the unit sine, then omega must have the unit of radian per second. And in fact, the angular frequency is nothing more than 2 pi divided by t. T is the period of the oscillation. So omega is here to define the period of frequency of the oscillation. What is omega t? When t is equals to 1 period. So 2 pi over period times 1 period gives you 2 pi. 2 pi is 1 cycle, right? That's why you have 1 oscillation, 1 complete cycle in 1 period. Basically, x naught scale your graph vertically to give you the amplitude of the oscillation, whereas omega scale your graph horizontally so that 1 cycle fits 1 period. So this is the starting point for our study of simple harmonic motion. It's one of my favorite topics, and I hope you'll stick around. See you! Ta-ta!